My name is Jenny Whitten. I am a research scientist at the Smithsonian Institution National Air and Space Museum. I have always been curious about things, uh, and I landed on science, actually oddly, because when I was in high school, there was a magnet schools, and I wanted to stay in the same high school that my friends were in. So I picked the science one because that's the one that I would have been assigned to. I know, terrible, right? Uh, it's just how it worked. So I stayed in science and I decided I really enjoyed it because I feel as though science is a big puzzle. And I really enjoy puzzles where you get small little pieces of that puzzle, little clues that you then have to piece together to form a greater understanding. And in college, I wanted to experiment with geology. I'd had the opportunity to do biology and physics and chemistry in high school. And I finally got the opportunity to do geology. And for me, that was a moment where I thought, wow, I can take all of these different sciences and combine them to discover how it, at least at the time, my understanding was Earth, very Earth focused. But now I know that I can take all those same concepts and apply them to planetary science. In terms of the VERITAS mission, I get to do a couple of things. I am the Associate Deputy PI, which has been very exciting for me. What that means is that I get to shadow both Sue Smekar and Darby Dyer, who are the PI and the Deputy PI of the VERITAS mission. I've in the past had the opportunity to participate on missions as a science team member, but this is the first time where I really get to see how it all works, how you gather the engineers, how you gather the scientists. I am also a science team member, and I am currently in charge of one of our 18 science requirements. My requirement is requirement number 13, and that is to look for new lava flows. And I'm going to be doing that using the synthetic aperture radar images. And then my last hat I'll talk about is that I am in charge of the SOAR program. That is the student collaboration program for the VERITAS mission. And that is an acronym that stands for Student Opportunities in Academics and Research, where we partner with Pasadena City College to involve students in their classes, but also in internships into various aspects of the VERITAS mission. I am, as I mentioned, the associate deputy PI, but the PI and the deputy PI are women, which is something that doesn't always happen and is very exciting to me to be able to see so many women in leadership roles. And then, fun fact: all craters, small craters, are named after women, just female first names globally, and then larger craters are named after famous women. I feel like that's a real nice treat that we get to have a female-led mission to a planet that has generally been associated with females. Why do we care that Venus is active? I think there are a lot of reasons. Some of them are really as a means of comparison with Earth. So we know, not that I have an Earth globe, but Venus is approximately the same size, the same density, and the same bulk composition as Earth. The surface geology has manifested very differently. My globe here is a topography globe, so I get a nice rainbow color here, but usually you see Venus in that orange color scheme that I'm not a fan of. And you see that it's dry, there's no vegetation, the atmosphere is dense and crushing, and it's not a very habitable place. So how do you have these two planetary bodies that are so similar, same place basically in the solar system, diverge so drastically? And one of the things that controls our world on Earth is volcanic activity. So, how do plates move on Earth? How do volatiles, so water and other elements necessary for life, cycle between the atmosphere, the surface, and the interior? And that is all linked to volcanic activity. So the work that I'm currently doing focuses on studying tesserae. These are ancient volcanic materials on Venus. On this globe here, I'm going to try and rotate it really slowly here, but you can see these redder, browner areas. These are high standing areas. I don't know if it comes out, but they also happen to be brighter in the radar data, which is the base of this globe here. And these are areas that we think may be distinct compositionally. We don't actually know the answer. That's one of the exciting things that VERITAS can address directly. Tests are very important for many reasons. One of perhaps the most exciting, in my opinion, is that some people have proposed that their lithology is silicic. So I'm going to be very general here and say kind of like a granite. And if you have 8% of the surface covered in granite, it suggests that water may have played a very important role in the production of that volume of granite. That could provide another piece of evidence to suggest that maybe there was a global ocean or an ocean of some size on Venus at some point in its past, which is a big point of debate in the community right now. There are so many open questions. There's Venus is so close to Earth, and yet we really don't know that much. We've sent, many more missions to Mars and the Moon. We've sent a more recent mission to Mercury and Pluto than we have to Venus. And so, given the technological advances that we have, I think we're going to be really surprised by Venus when we get there. I've had the opportunity to work on most of the rocky bodies in our solar system. So I really tend to approach planetary science in a comparative planetology framework. So taking a single process and understanding how it is expressed on different bodies based on the environments of those bodies. So I've done a lot of work looking at ancient volcanic deposits on the Moon and Mercury. So this is all relative, but things aren't that ancient when you compare it to the Moon and Mercury. So the majority of volcanic materials on the Moon and Mercury are, in the 3 to 4 billion year old age range. We think that the surface of Venus is relatively young, sort of 500 million years to 1 billion years. Just trying to understand how is this planet releasing heat? Where is it erupting materials? What is that telling us about its evolution? That is one way that I am using the extra time that I have now, is to try to learn new processes, new perspectives on different Venus science topics. Why Venus for me? I love the challenge and the flexibility that there is in Venus science. People haven't been focusing on Venus, and I think it's exciting. Venus is weird. It has an atmosphere that's difficult to see through. So you can't take a picture of the surface of Venus like you would with a normal camera. You have to use radar data. And radar data can be a little trippy, right? It's not going to show you the brightness of the surface based on, the color of the surface as we would see it in visible light. You're seeing those brightness variations reflect differences in the surface roughness. And so it's a weird way of thinking about an image that's not typical, which I enjoy the challenge. Not on this mission, but sometimes I'm in a room and I'm the only woman. That's crazy to me. And I think that it's really important to get a diversity of opinions. And the way that you get a diversity of opinions and you get a diversity of people in the room is by trying to inspire people as early as possible. So I think student collaborations, I think having interns as early as reasonably is a good thing. I think it benefits everybody. I am very excited about Venus science, and the VERITAS mission is really going to revolutionize our understanding. And I am just so excited. And I like sharing my excitement with the world. So that's always my goal with interns, with colleagues, with the general public, is to share my love of science. So it's a big, important thing for me.